Hi, myself Dr. Vinder Kumar. Today in this session, we will discuss about the quicksort. The quicksort is also based on the concept of divide and conquer, just like merge sort. But in the quicksort, all the major work is done while dividing the array into sub-arrays. While in case of merge sort, all the real work happens during the merging the sub-arrays. It is also called partition exchange sort. After selecting an element as pivot element can be any element from the array. It can be the first element or the last element or any random element. Here in our case, we will take the rightmost element or the last element as pivot. So here in quicksort, following are the steps involved in quicksort algorithm. In quicksort, we call this partitioning. We divide the array for the first time. It is not simple breakdown of array into two sub-arrays, but in case of partitioning, the array elements are so partitioned that all the elements smaller the pivot will be on the left side of the pivot and all the elements greater the pivot will be on the right side of it, and the pivot element will be at its final sorted position. The elements to the left and right may not be sorted. Then we pick the sub-arrays, elements on the left of pivot and the elements on the right of pivot, and we perform partitioning on them by choosing a pivot in the sub-arrays. So in quicksort algorithm, we have two functions. One is quicksort, second is partitioning. In quicksort algorithm, we have major four steps. First is make the rightmost index value as a pivot. Step 2, partitioning the array using pivot value. Third is calling the quicksort for the left partition recursively. Step 4, quicksort right partition recursively. And in partition function, we have 7 steps. Step 1, choose the highest index value as pivot. Take two variables I and j, point to the low index of an array. This is the I and this is the j variable. And then for loop in step 3, traverse all the elements from low to high except pivot. The step 4 and 5 are come under the step 3 in a for loop. If the current element of jth location is smaller the pivot, then increment in I and swap the ith with the jth element. After the completion of this for loop, swap the next to ith with the jth element. In step 7, return the next to ith element location that is acted as a pivot element, this I plus 1. So here we have example of quicksort algorithm. Here we have array with the 7 elements. These are 5, 9, 25, 100, 35, 45, 80 with the indexes 0 to 6. So initial set low is equal to 0, high is equal to 6 and pivot is equal to 80. This is the last element of our array. So we move j from low to high minus 1, means 0 to 5. So initial j is equal to 0, I is equal to 0. The jth element is less than equal to pivot, yes. Then increment in I and swap ith element with the jth element. Both are pointing to the same element, so no change. Then j is equal to 1, I is equal to 1. Now jth element is greater than pivot, no change in I and any exchange. So again j is equal to 2, I is equal to 1. Now jth element is less than pivot, then again increment in I and swap the ith element with the jth element. That means 90 and 20 are swapped with each other. This. Then j is equal to 3, I is equal to 2. Now the jth element is greater than the pivot. No change in I and any element in array. So j is equal to 4 and I is equal to 2. Now jth element is less than the pivot. Then increment in I and swap ith element with the jth element. So 35 is swapped with the 90. Now j is equal to 5, I is equal to 3. Jth element is less than equal to pivot. Again increment in I and swap ith element with the jth element. 45 is swapped with 100. So now we have this array. And after the completion of this loop, now j point to the next element, that is high. So finally place pivot at the correct position by the swapping I plus 1 with the array of high, that is pivot, means 80 swapped with the 90. So after this, now 80 is at its correct position. Hence, after the first pass, pivot 80 will be set at its position with all the elements smaller to it on its left and all the elements larger than to it right. Now 5, 25, 35 and 45, these become in a one sub array, and 190 are in another sub array, are considered as a two separate sub arrays, and same recursive logic will be applied on them, and we will keep doing this until the complete array is sorted. The quicksort is based on the divide and conquer algorithm. Quicksort to provide an average case performance that usually outperforms other sorting algorithms. The advantage of this quicksort is that we can sort in place, that is without the need for a temporary buffer depending on the size of the inputs. Quicksort partitions an array and then call itself recursively twice to sort the two resulting subarrays. This algorithm is quite efficient for large size data sets, as its average and worst case complexity are O n log n base 2 and O n square respectively. Thank you.